Hello everyone, let's solve problem 502, that is IPO. Suppose LeetCode will start its IPO soon. In order to sell a good price of its shares to venture capital, LeetCode would like to work on some projects to increase its capital before the IPO. Since it has limited resources, it can only finish at most K distinct projects before the IPO. Help LeetCode design the best way to maximize its total capital after finishing at most K projects. Okay, you are given n projects where ith projects has a pure profits of I. That means we are given a profits array. Okay, and a minimum capital of I is needed to start it. What does that mean? We will see. Initially you have W capital. When you finish the project, you will obtain its pure profit and the profit will be added to your capital. Pick a list of at most K distinct projects from given projects to maximize your final capital and return the final maximized capital. Okay, so this is what we have been given. Now what does it say? Ith project has a pure profit of profits of I. So for a project say 0, the profit is 1. For 1 it's 2. For 2 it's 3. Okay. And a minimum capital of I is needed to start it. So in order to do this project, you need to have this amount of capital at least. Now what do we have in our capital? We have initially 0. So with this capital, we will be able to start this project, but not this project, because for this project to start we need at least one capital. Similarly for this we need at least one capital. Okay, now what we have been said is that when we complete a project, okay, let's say we complete this project, okay, the profit of that project will be added to our capital. If we complete this project, this profit will be added to our capital. So this is what it is happening. All right, that means if we do a project and its capital is added to our and the profit is added to our capital increases and more number of projects become available to us, right? Now our task is to maximize this capital by doing the projects. Now how is this going to be, how are we going to maximize it? We are going to maximize it by adding the profits, right? Profits to it. And how can we maximize it? The only way we can maximize it is by doing as many projects as possible, right? But here is the thing, we can do at least at most 2 projects. Okay, we can do only 2 projects, at most 2 projects. Okay, so for that what can we do? Say if we are supposed to do only one project, let's say, and we have these profits 1, 2 and 3, which project are we going to choose? Let's say we don't have any constraint, we are going to choose this project, right? Because this has the maximum profit, isn't it? So what do we understand from that? We need the projects which have the maximum profit at first. We need them first. Okay, then serially we will take up the maximum. Okay, say we have 2 projects. If we do these 2, we have a profit of what? 3. If we do these 2 projects, we have a profit of 5. Let's just say. Okay, so the thing is we need the projects with the maximum profit. Okay, but we have this constraint as well, right? In order to do a project, we need at least that amount of capital. Fine. So the thing is, now if say our capital is initially say X, what projects will we be able to do? Only those projects whose capital is less than or equal to X, right? Let's say our capital initially is say 4. Okay, and the capital of say 4 projects is, let's say, 0, 1, 2 and 3. Okay, and their profits, let's say, are 3, 2, 4, 1. Now among these, and let's say we can choose only 2 projects. Which projects are we going to choose? We are going to choose this project and this project because they yield the maximum profit, isn't it? So from this we get the idea that if this is our capital which is less than our initial capital, we would need the projects which have more profit first. That is, we need them in a sorted fashion, that is decreasing order. It would be 2, then it would be 0, it would be 1 and it would be 3, because we can choose all of them because they are less than equals to X, right? So because they are yielding the maximum profit, we will choose these 2. So since we are going to need the projects with more profits at first, right? For that we are going to use a max heap. Fine. What will the max heap do? It will provide us the access to the maximum profits at first. Okay. But before that, these projects would be available to us if their capital is less than our capital, less than or equal to, right? So for that, what we are going to do, say we have these three capitals, okay, and initially our capital is say 1. Now in order to have a capital lower than our current capital, our capital, we are going to call these capitals one by one. In which way? That hey, whoever is the minimum, come to me at first. So what is the minimum? 0. Come to me at first. Okay, I will do some work on you. Okay, he is done. Then which is the next minimum? It is 1. That is less than equals to 1, isn't it? I will do some work on you, and eventually some profit would be added to this one, right? So it will increase, and more profits would be available to ourselves as we move on. Okay, so in this case our task is to get the minimum capitals to us at first. Okay, for that we are going to use a min heap. So let's summarize. For the capitals, we are going to use a min heap. Now this min heap will bring us the least capitals to us at first. Let's say our capital is W, and say we have 3 capitals available to us which is less than W. Now these 3 capitals would have some profit associated to them, right, for the project. Let's say 4, 3 and 1. Okay, now because these 3 capitals are less than W, our capital, then only we will be able to work on these profits, then only we will be able to get these profits, right? And which one would we choose? We will choose the maximum. So for that we will put these profits into our max heap. Fine. Now when our capital would increase, we will go to the next projects, if we can do more projects. Okay, now that we have the idea, let's try to code it. We are going to have a min heap for what? Initially the capital, right? Let's call it min c, in capital, new priority queue. What are we doing in this? Say these are the profits available to us, and these are the capital. Okay, now they are in pairs, right? They are related to each other. We can't just use the priority queue to sort them and leave them as it is, right? They will be shuffled, isn't it? So we will sort them together by keeping them together. Okay, now let's create our max heap. Let's call it max p, max profit, right? Priority queue. Okay, now in the min heap of our capitals, let's put the data. Profits dot length I plus plus min capital dot offer new int what? Capitals of I and profits of I. We are sorting it based on the capitals, that is a of 0 minus b of 0. Okay, now while k minus minus is greater than 0, we will work on k projects. Okay, while our min capital is not empty, minimum capital is not empty, and min capital, the peak element of min capital, it contains the capital of ith project and capital of profit of ith project. If that capital is less than or equals to our initial capital, while it is less, okay, we will add those profits associated to our max profit max heap. Okay, min capital dot poll 1 index 1, right? Profits is in index 1, this is index 0, index 1. Okay, what did we do? We did, so this was our, say this is our min heap. Okay, initially our capital is 0. What are the capital that are less than or equals to our current capital? It's this one only. So we will add this profit to our max heap. Now this is our max heap. Okay, what we will do, one by one we will add this maximum profits to our current capital. Okay, now we did only one project. Now let's move on. Our capital now increased from w0 to 1, isn't it? So these two are available to us now, and we are yet to do one more project. Okay, so what we will do, while min capital is not empty and min capital of peak of 0 is less than equals to this 1, this and this are less than or equals to 1, right? So we will add these two profits to our min max profit, that is 3 and 2. And which one will we choose? We will choose the maximum out of them, that is 3. That is what our max heap is for. Okay, w plus equals to max heap dot poll. Now there is one more condition. If our max profit heap is empty, we will break out. Why? Let's say at some point we have the capital of say 3, and the next projects that are available to us has the starting capital value greater than 3. Let's say the next projects that we have the capital 4 4 5 5. So there is no way we can start these projects, right? So in that case we are done, we will simply break out. Okay, and whatever profit that we have collected, whatever the capital that we have maximized, we will return it. So this is our code. Okay, let's try to run it. Accepted. Now what is the time complexity? The time complexity is, first we are iterating over the profits, and we are adding data into our min heap, right? That will be log n. Okay, then we are doing a operation k times, that is O of k. What we are doing, we are adding as well as polling or popping from our min heap, right? That is another log of n. So this is our time complexity, and our space complexity is big O of n, right? So this is the solution. I tried to make it clear. I hope it's clear for everybody, and in case you still have a doubt, you can ask in the comment section. I'll try to reply to them. All right, so yeah, if you like this video, hit the like button, share this video, and subscribe to my channel if you haven't, and I will see you in the next video. Bye bye.